Hello everyone, my name is Nikhil sir of support classes Sapirasti Road Sholapur. We have started 9th chapter in science of class 9 NCERT, that is force and laws of motion. In that we have studied some part of this topic in our previous videos. Those students have not seen my previous videos, please student go through my previous videos. I have given you links of those videos in my description box. You can please check my description box and go through those links. Now today we will move towards our next point in this chapter, that is questions. First question, which of the following has more inertia? We have to find more inertia in the following. First one is a rubber ball and a stone of the same size. Second, a bicycle and a train. See, a 5 rupee coin and a 1 rupee coin. And for answer, we will move towards the answer. See here the answer. First, we will talk about the inertia. Inertia means is the measure of the mass of the body. Inertia is the measure of mass of the body. The greater is the mass of the body, the greater is its inertia, and vice versa. Means if mass is greater of that body, it means inertia is also greater. If the mass of that body is less, that time the inertia is also less. Now in the first example, mass of a stone is more than the mass of a rubber ball for the same size. Means mass of the stone is greater or more than the mass of a rubber ball for the same size. Hence inertia of the stone is greater than the of a rubber ball. Next, I hope you understood it better. Mass is greater of the stone, that's why inertia is also greater to the stone. Second, mass of a train is more than the mass of a bicycle. Hence, inertia of the train is greater than that of the bicycle. Here, mass of the train is greater than the mass of a bicycle, so inertia is greater than mass of the bicycle. Now in C, mass of a 5 rupee coin is more than that of a 1 rupee because 1 rupee because inertia of the 5 rupee coin is greater than that of the 1 rupee coin. Mass is greater of a 5 rupee coin, that's why inertia is also greater. Now we will move towards next question. In the following example, try to identify the number of times the velocity of the ball changes. And the example, a football player kicks a football to another player of his team who kicks the football towards the goal. The goalkeeper of the opposite team collects the football and kicks it towards a player of his own team. First, what will be happen? A football player kicks a football to another player, to his team who kicks the football towards the goal, and the goalkeeper of opposite team collects the ball and kicks it towards a player. Then you have to identify the agent supplying the force in each case. See the answer, students, and the answer is in this way. The velocity of ball changes 4 times. How many times? 4 times. What changes? The velocity of football changes 4 times. First, when a football player kicks to another player. First, when a football player kicks to another player. Second, when that player kicks the football to the goalkeeper. Third, when goalkeeper stops the football. Fourth, when the goalkeeper kicks the football towards a player of his own team. In this way, velocity of football changes 5 times. We will move towards next question. Question number 3. Explain why some of the leaves may get detached from a tree if we vigorously shake its branch. See the answer. Some leaves of a tree get detached when we shake its branches vigorously because branches comes in motion while the leaves tends to remain at rest due to the inertia of rest. When we shake its branches of a tree, that time branches comes in a motion while the leaves remain at the rest condition due to inertia of rest, and that's why the leaves of a tree get detached. Now next question. Why do you fall in the forward direction when a moving bus brakes to a stop and fall backward when its acceleration from rest? See the answer. First, when a moving bus brakes to stop, our feet comes to rest with the bus. What will be happen when a moving bus brakes to stop? Our feet come to rest with the bus. However, upper part of our body continues to move forward on account of inertia of motion, and that is why we tend to fall in the forward direction. And in the next case, when the bus accelerates from rest, lower part of our body moves with the bus. See what will be happen when the bus accelerates from rest, lower part of our body moves with the bus. The upper part of the body tries to maintain itself at rest on account of inertia of rest. Therefore, we tend to fall backward. This is the answer. I hope all the answers of this question you understood it better. Please student, now I will show you some examples of Newton's first law of motion via some videos, and this video is also available on the YouTube. See the Newton's first law of motion, some experiments.
Newton's first law of motion.
Wait student, I will make some clarity. I will also increase some brightness.
In our everyday life, we observe that effort is required to put a stationary object into motion or to stop a moving object. Have you ever wondered if a ball kicked to the ground would keep moving forever, or after some time would naturally stop moving? The ball will continue to move unless an object of force stops it. Here comes Newton's first law, which states a body continues to be in its state of rest or of uniform motion unless acted upon by an unbalanced external force. To understand Newton's first law, you need to understand what unbalanced force is. If you have seen a game of tug of war, you would have seen two teams pulling a rope in opposite directions. If the rope doesn't move, the forces applied by the teams are balanced forces as they are of equal magnitude in opposite direction. If one of the team applies greater force, it pulls the other team and the rope towards their side. In this case, the forces are unbalanced as the two forces are of unequal magnitudes in the opposite directions. If one of the team lets go of the rope, the opposite team falls backwards. This tendency to fall backwards despite letting go of the rope is due to inertia. That is, if an object is at rest, it tends to remain at rest, and if it is in motion, it tends to stay in motion. This property of an object is called its inertia. Inertia can be classified into three categories: inertia of rest, inertia of direction, inertia of motion. Certain experiences that we have while traveling in a bus can be explained to the basis of the law of inertia. When a passenger is standing in a stationary bus that suddenly moves, the movement pushes the passenger backward. Why does this happen? This is due to the inertia of rest experienced by the passenger in the upper part of his body. The body is at rest when the bus is at rest. When the bus starts, all of a sudden, the lower part of the body is in contact with the vehicle that started moving, whereas the upper part of the body continues to be at rest because of the inertia of rest. Inertia of rest is a tendency of a body to resist any change in its state of rest. What happens when a fast-moving bus negotiates a right-hand curve on the road? The passengers will tilt to the left. Inertia of direction is the tendency of a body to oppose any change in the direction of its motion. With the application of sharp brakes, the bus stops all of a sudden and the passengers tend to fall forward. This is due to inertia of motion experienced by the upper part of the body. When the bus is moving, the whole body of the passenger is in a state of motion. A sudden halt caused by the lower part of the passenger's body that is in contact with the bus comes to rest. However, the upper portion of the body remains in a state of motion due to the inertia of motion, causing the passenger to fall forward when the bus stops suddenly. Inertia of motion is a tendency of a body to resist a change in its state of uniform motion. Thus, Newton's first law is also called the law of inertia. Well, now this law should make sense. Do you understand why a ball on the ground, after being kicked, does not keep moving forever? The ball stops after some time due to the unbalanced external force applied by the ground in the opposite direction. Things to remember. Newton's first law of motion states that a body continues to be in a state of rest or of uniform motion unless acted upon by an unbalanced external force. Two unequal, oppositely exerted forces are called unbalanced forces. Newton's first law is also known as the law of inertia. The tendency of an object to continue its state of rest or of uniform motion in a straight line is called inertia. The three types of inertia are inertia of rest, inertia of motion, and inertia of direction.
I hope you will understood it better. If any queries regarding Newton's first law, you can ask me. We will solve your problems. Now next part we will see in our next video, that is second law of motion. Please student, subscribe my channel and show your thumb. Please share this video to your friends, neighbors and relatives.